Welcome, everyone. Today, we're diving into wet metallization process solutions specifically designed for glass substrates. This presentation explores advanced packaging technology that addresses the evolving needs of high-performance electronics. We'll look at how these processes enable superior electrical performance and reliability in next-generation devices. Let's get started by understanding the core concepts and innovations driving this field. To guide us through this topic, the white paper is structured into clear sections. We'll start with an executive summary to frame the discussion, then explore why glass substrates are becoming essential now. We'll examine market drivers, the advantages and challenges of glass, and why wet metallization processes offer a compelling solution. From there, we'll delve into specific technologies, applications, manufacturing integration, and finally, key takeaways and references. This roadmap will help us navigate the technical details effectively. The industry is shifting rapidly towards advanced packaging, driven by the growing demand for high-performance computing and artificial intelligence. Glass substrates are emerging as a strong alternative to traditional organic materials, offering exceptional electrical properties and dimensional stability. The key challenges in plating on glass, adhesion, seed layer deposition, and through glass via filling, are addressed by a validated wet metallization process. This approach supports fine-line patterning and works across multiple glass types, delivering superior coverage, productivity, and signal integrity. Our insights come from a team of experts with deep experience in surface treatment and plating technologies. Dr. Thomas brings a strong background in chemistry and product management, focusing on surface treatments. Henning Hübner specializes in panel and pattern plating, contributing to advanced packaging chemistry development. Roger Massey offers extensive expertise in materials and microstructural engineering, with a focus on plated through holes and process engineering. Together, their combined knowledge shapes the solutions we'll discuss. So, why is glass gaining traction now? Glass substrates combine properties that are difficult to achieve with organic materials: excellent dimensional stability, low warpage, smooth surfaces, and tight registration. These enable fine-line lithography and higher interconnect densities, essential for modern electronics. Glass can replace traditional laminates, improving electrical performance and enabling through-substrate interconnects. Market demands like increased interconnect counts, fine pitch redistribution layers, larger substrate sizes, and reduced signal loss are driving this shift from pilot projects to manufacturable flows. Glass substrates offer clear advantages over organics, including superior dimensional stability, flatness, and electrical properties that support low loss and high frequency. They also enable fine-line capabilities down to 5 microns and support larger panel sizes. However, metallizing glass presents challenges. Adhesion is difficult due to the inert surface. Seed layer deposition struggles with high aspect ratio features. Through glass via filling must be void-free, and process integration requires careful handling due to glass brittleness. Addressing these is critical for successful manufacturing. Wet metallization processes provide significant benefits compared to traditional physical vapor deposition. They enable higher productivity through simultaneous double-sided, multi-panel processing and achieve conformal coverage for aspect ratios exceeding 10:1. Unlike PVD, wet processes avoid titanium adhesion layers, reducing signal loss and simplifying seed layer etching to a single copper-only step. The process flows through dip coating, electroless copper plating, and electrolytic copper plating, each contributing to robust adhesion, uniform seed layers, and void-free via filling. VitroCoat GI acts as a nanometer-thin adhesion promoter, forming a strong chemical bond between glass and copper through a sol gel process. This involves dip coating for uniform coverage, pre-baking to densify the gel, and sintering to create a crystalline metal oxide layer that diffuses into the glass. Following this, Atotech deposits an electroless copper seed layer that ensures uniform thickness and excellent coverage, even in high aspect ratio through glass vias. Together, these steps establish a reliable foundation for subsequent copper plating. Feeling through glass vias is one of the toughest challenges. The InPro Pulse TGV process uses pulse and reverse pulse plating to balance additives and direct copper deposition toward the via center, achieving void-free fills with minimal overburden in a single step. This technique currently supports aspect ratios up to 6:1, with development ongoing for higher ratios. After metallization, standard downstream PCB processes like lithography, electrolytic plating, resist stripping, and seed layer etching can be applied seamlessly, enabling full circuit formation on glass substrates. Glass substrates target key applications in advanced packaging. The 2.1D glass core package substrate replaces organic cores in high-performance packages, offering thicknesses from 300 to 1200 microns, improved vertical I/O with fine pitch through glass vias, and enhanced warpage behavior for reliability. Meanwhile, 2.5D glass interposers serve as cost-effective alternatives to silicon, with thicknesses between 100 and 400 microns, better scaling, lower manufacturing costs, and reduced signal loss and power consumption. These applications highlight glass's growing role in next-generation electronics. Integrating glass substrates into manufacturing requires specialized handling due to their brittleness. Panels up to 515 by 510 millimeters have been demonstrated, but care must be taken to avoid edge cracking and mechanical stress during processing. Mks Atotech supports this integration with tech centers in Yokohama and Guanyin, equipped for vertical electroless copper and hoist-type electrolytic plating on large panels. This production sampling capability helps customers validate processes and ensure smooth manufacturing transitions. In conclusion, plating on glass is now a viable manufacturing path for advanced packaging. The core challenges, adhesion, conformal coverage, and void-free filling are effectively addressed by VitroCoat, IR, GI, Atotech GIM, and InPro Pulse TGV technologies. These processes support fine-line patterning down to 2 microns, reduce signal loss by eliminating titanium layers, and simplify processing with single-step copper etching. Combined with tech center support and proven recipes, Mks Atotech is ready to help customers achieve high-volume manufacturing success with glass substrates. The references listed here provide the technical foundation for the processes and challenges we've discussed. They include detailed studies on glass metallization, adhesion promotion, and wet chemical copper metallization from leading researchers and industry experts. These sources validate the approaches and innovations presented, offering further reading for those interested in the scientific and engineering aspects behind wet metallization on glass substrates. Before we finish, it's important to note the general terms and conditions. All information is provided as is for informational purposes without warranties. Mks Atotech assumes no liability beyond product quality, and users are responsible for evaluating suitability for their applications. For any difficulties, technical support is available. Copyright is held by Atotech with all rights reserved. This ensures clarity on the use and interpretation of the material we've covered today.